Welcome, welcome, welcome. We're so happy you're here for the Autodesk Teaching with Tinkercad webinar with our special guest, Scratch, and also our friends from Olin College as well. So this is going to be a very special, warm and fuzzy episode to ride us into the computer science education season. So we are super excited that you are all here to join us. And again, if you're looking for the Teaching with Tinkercad webinar series, you are in the right place. And even if you weren't, you should stay because hopefully it'll be fun. So we're going to just get started with a warm-up question. We know that AI and teaching with AI is something that is on your minds in the classroom. So we're wondering, what is just one word? Try not to use any bad words. But what's one word that you would use to describe how you feel about teaching with AI right now? We're going to be engaging in, I think, a really interesting conversation that I think will help build your confidence around teaching with AI, or at least ease some of your anxiety about it if you do have any. But we'll get started with that in a minute. For now, we just want you to warm up the chat. We also, one of the things we love the most about the Teaching with Tinkercad webinar series is the global footprint. How many teachers from all over the world are here joining us. So please feel free, this chat is your chat, so please feel free to share, a hello to other teachers around the world. You can let them know if you feel comfortable where you're teaching from. Randy, how are we feeling?
We are feeling a lot of excitement, anxiousness, empowerment, intrigue, some worry, um, more excitement, hopeful, um, challenged, a whole range of emotions here.
And that makes sense. I think that that's very valid. A range of emotions is definitely something that I think we're all feeling, regardless of what our current role is at work. So do please keep using the chat to say hello to each other, to say hello to us. But I'm going to get started with the formal program because we have a lot to cover this evening or day or morning, wherever you are, whatever time it is. So again, this is the Teaching with Tinkercad webinar series. And we are super, we've been planning this since like early this year because we're so excited about our special guest, Scratch, that is joining us tonight. So Maren from the Scratch Foundation, so that we can talk about an interesting workflow from Tinkercad to Scratch to help you get ready for Computer Science and Education Week and even Hour of AI. So our theme tonight is Code, Create, Connect with Tinkercad and Scratch. We thought we'd get started just because we feel like there might be new audiences here tonight from our friends at Scratch. So we wanted to start with a poll early, just so that we could find out from you what are some of the subjects that you teach or support. I believe I made this poll so that you can choose more than one. So seeing a lot of technology and computer science, which definitely seems relevant to this evening's presentation. Love to see the art and English language arts. The project that we are presenting tonight is very interdisciplinary. So it would be great for all types of subjects. So we'll end this poll and then move on to the next poll. So we also were just interested, just so that we know, so that we can kind of tailor what we're saying to the audience. So we're wondering, in your classroom, do you currently teach with Tinkercad? Do you currently teach with Scratch? I love the both. I mean, that's what we're trying to encourage tonight. And then also neither. So we have some newcomers, so welcome. You're in store for a lot of fun tonight, learning from both the Tinkercad and Scratch teams. And we'll just give it a few more seconds on the poll. We appreciate you participating. And again, do continue to connect with each other in the chat. We always learn from you as part of these webinars, and that's what we love about them so much. So Randy, I think we're good with the poll. So I'm going to clear that out off of my screen. Just because, we're welcoming new audiences to this webinar, so we just wanted to get you kind of ready If you want to join along, if you want to open up another screen and kind of check out some of the resources that we're sharing or another window on your browser, you could go to tinkercad.com to log in. If you don't already have an account, we encourage you to create one. Same for Scratch. So you might open up another window in your browser and go to scratch.mit.edu and set up your account. This is not necessary, but we just thought that this would be good information to share. So excited about today's facilitators and speakers. We will have Guillermo Melatoni, who's the Director of Product Management for Autodesk Fusion and Tinkercad. I haven't even introduced myself yet. My name is Kellyanne Mahoney, and I'm an Education Marketing Manager for Autodesk. Prior to joining Autodesk, I was a teacher, middle school, for 13 years in the Boston Public Schools. So always happy to be back with my people. We also are joined by Dr. Amon Millner, who is a professor of computing and innovation at Olin College of Engineering, and our friend Maren Vernon, who is a learning resource designer for the Scratch Foundation. So just quickly how to participate. You'll see at the bottom of your screen, there's the message box for you to message with each other in the chat. There also is the Q&A tool. If you have a question that is specific to like your situation that you want to have answered by the Tinkercad team, also Maren is here to answer questions about Scratch that might be particular to you. So if you have a very particular question, please use the Q&A tool in order to ask that question. And we're going to try to get you your answers in real time. And we also will have a question and answer session at the end. So the goal of this episode is really to, I think ultimately to help you build confidence and fuel your imagination and find inspiration for for Computer Science Education Week and beyond. So Computer Science Education Week is from December 8th to 14th this year. It also encapsulates the new Hour of AI, formerly known as Hour of Code. So the activity that we are sharing tonight is meant to help you prepare for that and just to make sure that what you're doing with students is bringing coding and making and creativity together, and also to kind of give you some ideas, in thinking about AI is new for all of us. So Dr. Amon Millner is going to really help us think about how to kind of frame that conversation and to kind of inspire your thinking about what the possibilities could be in integrating AI into your teaching and learning. So our agenda for this evening, we're going to begin with Dr. Amon Millner, who's going to talk to us about reimagining computer science education with AI. Next, we'll hear from Guillermo, who's going to talk about this fun new activity that we created that is called Lighting Up a Story with Code. And it is a workflow that goes from Tinkercad into Scratch into an optional extension that is face sensing AI. So after Guillermo speaks, we're going to hear from Maren about how you could take your lighthouse design that we're going to be presenting and animate it and use it as a vehicle for telling stories and sparking your students' imagination. And at the end, then we'll have our question and answer session. So I am going to pass the mic right now, very excited to Dr. Amon Millner to talk to us a little bit about reimagining computer science education with AI. Dr. Amon Millner, please take it away.
Thank you for that introduction. I'm going to take away the slides and present. Okay, so you should see what I'm seeing, and I will welcome you again. Thank you for joining us. I'm going to talk about maximizing the creative partnership potential of AI while minimizing mischief, just to have a little fun to kick us off here for the first 10 minutes or so. I'll tell you a little bit about my main professional identity. As Kellyanne mentioned, I'm a professor of computing and innovation at the Olin College of Engineering. And as you'll see in the coming slides, I make tools, technologies, and contexts for creative learning, including connections to the webinar guests, Scratch and Autodesk. I was one of the core team members that introduced Scratch 1.0 and 2.0. So one of the OG Scratchers. You can still see me as one of the sprites if you're looking hard enough. And I was about a decade ago a faculty fellow that was helping Autodesk launch Fusion 360, one of the tools that's not Tinkercad, but also has some connections to AI, which is one of the themes of this Hour of AI webinar. So you'll hear me connecting to Scratch and Fusion 360. But first, I'm going to take a pit stop and introduce this tool, which many of you may be familiar with. It's a Swiss Army knife. You may have found lots of creative uses for these multi-tools that have everything from can openers to corkscrews, nail files, and blades. You can use them for a great many things, including it can be a creative partner. We just finished Halloween in the United States, and some people carved pumpkins. You could do great detailing. But because I mentioned mischief, people can also use things like Swiss Army knives to be an agent of mischief. And you can see some trees in a nationally protected park that have initials in them. And those sort of things can be one person's creative endeavor, but can also trigger a lot of other carving in trees that creates a landscape that's not what others came there for. So I'm just using the term mischief for things that aren't always on the up and up. So we think about Swiss Army knives as they do have double-edged blades, right? They do a lot of creativity and expression. They can also afford some things that are mischievous. And some people choose when to give access to these types of tools to young people, and they're trepidatious. Some people give them early, depending on their context, and other people wait a long time to give something that has this power to do both things. So I'm going to kick off there, but I'm going to go into artificial intelligence with a little bit of history to bring us to where we are today. So the name AI, you'll see in the coming slides, I'm going to play with those initials, but I'm going to go to 1956 at a summer camp conference at Dartmouth in New Hampshire. There was this when artificial intelligence got its official name, and it became a field 70 years ago. So most people think that a lot of things are new. Actually, the ideas started long ago. And in the 1960s, there were efforts like ELIZA that wanted to try to fool users into thinking that a psychotherapist was typing responses to something that you typed in by using a Rogerian method like a human would. So there was an attempt to try to fool humans with low-powered computing back then, and early AI work, and this is from the 60s. A lot of people recognize that machine learning is something that is tightly coupled with the term artificial intelligence. And there were efforts to learn how to play checkers. I'm just pulling one example from the 90s that talks about machine learning in a constrained space like backgammon. And machine learning allows the computer, which is a little more powerful in the 90s than they were in the 50s and 60s. This 1992 machine you see pictured could play 300,000 games of backgammon in a month and then be competitive and maybe beat humans. And a human master would play maybe 100,000 games in their lifetime. So this is a couple more years in the future. AlphaGo is a game that has infinitely more moves than backgammon or checkers. And the computing power and machine learning power evolved to where millions of games are being played, to the point where intelligence start to spring from move number 37 in this game against the champion from South Korea, where move number 37 was something that no other human would make. This AlphaGo AI had done enough learning on its own to do something that looked surprising to humans. And therefore, when it won that match, many people, chess masters, Go masters, start to train with these AI tools because they're able to reinforce their own learning by playing against themselves millions of times over. And that led to AlphaGo is now one of the biggest breakthroughs in our generation, is led to AlphaFold, where biology and other scientists can take the power that's using generative AI, but not in the ways that most people are talking about it today, but generating how proteins fold if you give them a combination of amino acids. And this is so accelerating how we can do drug discovery. And it is a marvel in artificial intelligence evolution because it evolves and folds many different proteins, if you give it some constraints to think about, it will actually make the shape. And it is not using large language models. There are different models that are generative for AI that aren't associated with the term Gen AI that most people associate with things like Chat GPT, because people are talking to them using regular speech as they would talk with friends and getting feedback. So they dominate the headlines, but I just going back to show you that there are a lot of other branches of AI, and we'll be covering some of them later in this talk. And I also wanted to contrast that ChatGPT is leveraging computing that's so sophisticated that it can actually convince you that you may be talking with another human, and it's actually programmed to not do that. Whereas Eliza was trying to fool you, ChatGPT and other tools try to not do that because it can get in trouble. So we got the definition of artificial intelligence from 1956 with AI, but I'm going to be overriding the A for a couple of other examples in the coming slides that involve amplifying power of it, amputating, augmenting intelligence, attenuating intelligence, amazing people and annoying people, because it does all of the things just like a Swiss Army knife. So some of you can recognize this memoji, which is something that has learned how to track eyes, nose, and mouth. And it lets you express yourself no matter how you wake up and your hair is, you can still put yourself into this frame and talk to other people, send messages. And that can amplify your expressive capabilities, but it can also amputate maybe some of your job. If you do like this lawyer in the other image, where the lawyer was using a Zoom filter as a cat on an actual hearing where that's probably not accepted, and didn't know how to turn that filter off. So some of these AI things that are amplifying and allowing us to present ourselves in lots of ways, we still have to be mindful of how we present ourselves, especially at work. And I believe later on, an Easter egg here, Maren may do a little bit with some of the recognizing where your nose is. So I won't spoil that or steal the thunder, but I will talk about how in computer science education, you're seeing AI evolve how people take traditional things in programming, such as doing unit tests to test the things that they're building as they're writing code or functions. Things like Copilot, you hear a lot about. And even though a person can develop the skills to do unit tests, sometimes it's daunting. And if you can generate a lot of tests, sometimes you see tests for your own work based on the corpus of other tests that lots of other creative coders have used that may teach you something about the art of doing testing by bringing in some tests automatically. So that's one of the uses of AI in modern computer science education, is helping with things like unit testing. AI can also augment and attenuate. So if you have taken a lot of photos on a smartphone, you have them in a repository. Sometimes it's online, sometimes it's on your phone, and you can't recall when you took a picture of a dog. And you can type in, look, dog, let me see when the last time I took a picture of my dog because I want to send it to someone. You no longer have to sift through all your pictures and try to remember the date. AI can search photos based on how they understand dogs' features are and get you straight to those pictures. And anytime you have AI tools that are developing, they don't start off at our intelligence. Sometimes things and tools can get in a lot of trouble. If you look at this picture that has some faces, you can see that it's not labeled friends or a particular person's name, it's labeled gorillas. And that was particularly offensive to the person that posted this image as one of the growing pains. Machine learning involves trying to make educated guesses and what's the probability of, am I going to make the right prediction? But sometimes they get things wrong. So we need a lot of people that are contributing to AI to make it so that these mistakes are fewer and farther between. Also, most people talk about AI and the ChatGPT landscape, but they don't think about AI in other places, such as on a camera, on a smartphone, where you can do things like in image processing, filter out and take better pictures in low light, where you don't have to have the skills of a photographer to manage the exposure and things like that. So, you may no longer wish to pursue the field of photography if you have all these things in your pocket. So AI can sometimes attenuate some skills or things that you would otherwise be into. Because we made the case for how coders are going to use computer AI and how they write computer code and unit tests. There's also in CAD generative design is something that Autodesk introduced with the Fusion 360 tool that I mentioned around 2018. They were thinking of ways where you can generate designs that consider the enormous number of things that must be considered when you're using CAD and manufacturing and where electronic wiring will go. You can have it generate designs that are based on a lot of other smart people's designs that may not occur to you. And even if you know how to draw and generate things on your own, by seeing a lot of examples, you can get inspiration. And they've already considered some of the manufacturing, some of the constraints that are just part and parcel with your craft. So it allows you to see a lot of different ways to do things. Even so, it allows you to expand your possibilities in the field of CAD and CAM and provides it in the tools. So I get a chance to think about what can amaze people about AI and what also annoys people. I gave you some examples of great, drug discovery, making coding more efficient and more inspirational, and you can learn from a lot of other people. But I also want to always talk about the double-edged sword, like the Swiss Army knife of AI, because young people deserve a chance to understand what it can do well for you and where there are places where it can still be improved. And we try to capture that in the show that I'm a curriculum developer for, that shows on PBS Kids, where we have that little blue guy, Stu, is kind of like a walking and talking virtual assistant that can amplify your ability to do something and get you into a lot of mischief. And you have to figure out how to get out of it so that you can see that there are still places where AI needs work. And you can think about how to make AI better. And one last override for the letters AI is we need authentic instructors to just bring your own experiences to help shape the future of the people that are going to be molding AI where it goes, because by no means is it perfect. It's a learning process. We're still going to evolve and have more of those breakthroughs on the timeline. The next 70 years are going to be very exciting. And the perspectives and the people that shape AI are going to be like a Swiss Army knife. We need a lot of different people that are used like the one. You don't open up a Swiss Army knife and use the nail file for all of your uses. You use the different tools. There's things that are better at certain tasks. We need a lot of perspectives to make AI what it can be, because you can see it's not just limited to CAD. It's not just limited to coding. It's everywhere, and it's going to continue doing so. So I appreciate all of you instructors here that are taking in this webinar to help unlock the next generation of the folks that are going to be shaping AI. And here's a question I want to leave you with. Thank you for listening to me, and I hope you enjoy the next couple of guests, because they're truly amazing.
Thank you, Dr. Millner. And when you're sharing about the Swiss Army knife, it's like making me think that that's a tool that's more refined than AI is right now. Like AI is something that we can continue to shape, and I think that that's a really powerful message to share with students, is like we need more inputs to help us shape it. So our question, thank you, Dr. Millner, for putting it up there for us, is how can you help students see AI as something that they shape, not something that shapes them? So powerful question to think about. It's an exciting, like a hopeful question to think about, I think, too. So I'm going to now share my screen and switch it over so that we can introduce Guillermo. So do keep sharing your thoughts. This might be like a short response question or a mini essay. So feel free to get out all your feelings about this. So next up is Guillermo, who's going to talk to us about lighting up a story in Tinkercad codeblocks. So Guillermo, please take it away.
Hello, everybody. Happy to be here after a 12-hour flight, so it's a long day.
You're a trooper, Guillermo. Thank you.
Yes. But I know it's very late for many people here too. I've seen they're coming from South America, from Europe, from everywhere. So thanks for being here. Before going directly into code blocks, and given that there's a lot of people that got very excited about this, and we're coming from the Scratch side of things that might not know a lot of Tinkercad yet, I just wanted to do a super quick introduction of what is Tinkercad and who is it for, just in case you are some of the people that said that you're only using Scratch, and then I can focus a little more on code blocks. So if you can go to the next slide, Kellyanne, please. There you go. I'm supposed to want to be tired, not
Sorry.
So yeah, Tinkercad. When we build Tinkercad, we're thinking about K-12, right? K-12 students getting into the world of STEAM, right? So and when we look at K-12 and even eventually more like post-secondary and getting into the professional world, we really like to focus on I would say somewhere between middle elementary school and all the way into middle school and a bit of high school. At some point, if you're really wanting to develop yourself into like a STEAM related career, you probably want to start using a Fusion or a Revit or a Maya or the different things that we have at Autodesk. But at the very early age, a product that is not scary, easy to learn, and that is very relatable to things you might know from before, like using Scratch or like doing Google Slides and knowing how to resize things, or playing with any brand of bricks, right? So I don't get into trouble. All of those things help you understand how to start building, right? So the whole point here is that we want kids of all ages, but again, starting at that very early age, to understand it's very interesting to see how to solve a problem by building a physical artifact, right? That can have that be 3D, that can be printed, that can have electronics, that can be built in 3D in different ways. So more programmatic, like code blocks, or more like direct modeling, and all of that will lead you then, if that gets you excited to become an engineer, an architect, different stimulated activities, to understand how they work in with all the tools later. So moving forward. Yeah, and Tinkercad historically started as a system of aggregation, right? So you put together pieces, right? So in the same way that I always say the same, because I remember that my kids' first kindergarten and first grade classes had a bin with a lot of these like shapes in wood, right? And different, very colorful. Most of them platonic solids, I would say. Yeah, most of them. But basically things you can build with, right? When we started with Tinkercad, we could imagine Tinkercad as that, right? As something that could allow you to put together things, and of course also subtract, which you cannot do with on a real wood thing unless you have a chisel or something that cuts. But then you could do that in Minecraft, for example, right? So sometimes when thinking about how to design, I don't know, a chair like that one up there, maybe if you're a little trained, you will say, okay, well, I can divide that into parts, into the seat, into the rest, into the legs, depending on what's the design, right? You might do different things, but for many kids, probably will be more like the one on the far right, right? It's 240 blocks, right? In the way you would build it in something like Minecraft, which I don't say every kid, but just a lot of people have gone through that, which is aggregation and mining, which is abstraction. This is what we do on Tinkercad. Of course, now we added Sketch and stuff like that, so now it's a little more less of that, but still making sure that every experience is as simple as we can and yet super powerful. Next slide. Yeah, and it's not just 3D. I mean, I know that we are very well known for the 3D workspace, which is the first one, right? The one that started in 2011, and he's still very loved, and actually, I don't know if you have seen any communications, but we have already gone past 100 million users that have been using Tinkercad for since the beginning. So that's 1% of world population, just in case, just because I can brag here. It's more than 1% of that. But so at some point we said, okay, well, we always had to be listening to what STEAM means to teachers, right? So electronics started becoming very important, right? So we added circuits, we added Arduino with coding, and actually also using Scratch, because not everybody wants C++ or can learn C++ that fast. The same with microbit later with Python, but also designing via visual programming, right? Because again, we knew there was a lot of kids that were coming already with experience in Scratch, like in a 2D world, right, of sprites and things that move around on a flat screen mostly, and there was a world in which we could actually take them into a third dimension and put all that together. So I think that was the last slide. Yes. So what we're going to be seeing today is I'm going to be just talking a little bit about code blocks, so we all kind of have the same same language here, and that's also like a prequel to what Maren is going to show on Scratch later, because we're going to be talking about a workflow that goes from one to the other. And the good news is that if you know Scratch, you'll pretty much understand this pretty fast. I mean, you'll just need to understand some concepts about 3D, but that's all. And yeah, we're going to be building a lighthouse. I see very original lighthouses there. Okay, and we're going to be like a one that looks nicer than those, probably, right, Maren?
Those were mine, Guillermo.
Okay, I'm so sorry. I'm so sorry. Yeah. So yeah, you can build anything, right? So,
Let's make anything, Guillermo.
there you go. So I'm gonna maybe share my screen now, and I'm also gonna show a little sneak peek of something that's not out there yet, but will be out there in a couple of weeks, maybe. So okay, share my screen. So why do we care about programming for 3D, right? So first thing I'm gonna do is actually not on code blocks, just to see the reason why sometimes you want to do stuff like that, right? So, and I'm gonna go super fast because the whole point here is talk about the lighthouse. But let's say I wanted to have something like a box. I just added a box, made it flat, right? And because I want to make a planter, right? So now I'm gonna do duplicate, which is Command D, move this thing up here, but with a little overlap, and make a little rotation. And the duplicate command is very nice because if you don't deselect, you can keep pressing Command D and doing more of these. So all of a sudden you have, and of course, if you then just add a hole here, and of course it has to go through the thing, and you make a group, ta-da, you have your planter. Now somebody asks you, okay, I need the hole to be bigger. Well, that's an easy one. So I'll just do this. So that was easy. But now the next one is not easy. Okay, I want the rotation to be 5 degrees and not 7. Oh, I had to start again, right? Or I want more of those. It's kind of a little difficult, right? Or whatever combination of I want to something. And when you're designing, one of the most important things in your life is the what if, right? Because it's when you're starting to think about different options, right? Your first option is never the best one, right? Ask Edison and the light bulb, right? So there would be no light bulbs if he had stayed with the first one. It would probably exploded, right? So same here. So then enter code blocks. And because why? Because when you're working with a programmatic approach, we can. So now I'm going to create the same thing, but with code blocks. And when you get into code blocks, if you never did it, you have exactly or pretty much the same shapes and many of the same options than the Tinkercad 3D workspace. So in here, and again, if you use Scratch, you just know that you have to drag something here. And in this case, I'm going to keep it by 20 by 20, but maybe I just make it like 20 by 20 by 3. That's fine. So if I hit play, I have a box, which is okay, nothing shocking. And now I'm going to do repeat, in which, and then you can, if learning moment, you can talk about loops, for example. And what you're going to do now is I'm going to copy the previous one, move it up. I want to have an overlap, so 2.5, because it's less than 3, so there's an overlap already. And I want to rotate around which axis? The Z axis, because X and Y are on the plane, so Z is the one that goes up. Z if you're in Canada or the UK, so it's multilingual. Z, perfect. And I'm gonna say like, I don't know, 5 degrees from the pivot. So now if I put anything more than one time, because one is not very exciting, a repeat of one is kind of boring, right? So I get exactly the same thing I just did. What is the good thing about this is that now you could say, okay, maybe I want 12. And I want 10 degrees. And that's what you got. But then also you have variables, which are very good when you want to do a lot of changes and keep doing changes. So I'm going to make a variable called repeat. And I'm just going to say, okay, this is coming here. I'm gonna set the variable as like in 12 at the beginning, and then just because I can, I'm gonna do another thing, which is that I'm gonna make the rotation be a number that makes the full thing go a full loop. So the angle of the rotation is going to be 360 degrees divided by repeat, right? So for example, if you had 5 here, you'll get this, right? So the last one will have the same orientation as the first one. That will be a little difficult to do with direct modeling. Or you could do some math, right, and do it. I mean, it's not that difficult, really. But if you said 15, well, I mean, that things are starting to get more complicated, but you get exactly what you wanted, right? So lots of iterations, a lot of what if. Again, what if is the magic question when you are designing, because that's the one that gets you to iterations, which is the base foundation of the design thinking. Got it? So now I'm going to show you a slightly more kind of involved code block, which is the lighthouse. The reason I started with something simple was to show this is easy, because if we start something a little more complicated, it might get intimidating, but just in a couple of seconds, you can do something really, 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 really nice. So this one is, it's a little, again, as I said, it's a little longer sort of code. I'm not gonna rebuild it, but I'm gonna explain some things here. But basically the important thing here is that when you play it, it's building each of the parts, and here is the lighthouse, right? And there's also some variables here. So I could change tower height to, I don't know, to 100 and play it again. Yep. And here it is. No? Ta-da. Right? So those things are, I mean, this is the power of code. This is the power of using variables. This is the power of using things that can basically contain a value that you can set at any point. And when those variables also are starting to relate to each other and make operations between each other, it's getting more and more interesting. And then when you go into the professional world, there's something called parametric modeling, which is kind of this, but much more, not complicated, but much more sophisticated, right? So it's hard to start there. Starting here gives you the foundation on a place that's safe, that's fun, that it's simple, that's not scary, and then you can go to whatever it goes next. So in this particular case, so you know, we decided here to define templates. Really, templates for something that's going to be a single object, it's not that important. But if you wanted to have several lighthouses or one object here that, for example, here we have this this path with a railing, right? If I wanted to have 3 of those, right, I could define one template, repeat it 3 times, and then if I change the template, all of them change at the same time, right? So there's a lot of power again on that repetition, and so here what happened is we define the template for the roof, which is basically a cone. We define the template for the housing for the light, which is a polygon. So it is a tube that has 6 sides. So it's basically like a hexagon that's hollow in the middle, and with holes done by boxes, and then repeated a couple times. The same for each of the other parts. So again, I don't have to go for everything, because if not, it will take a lot of time. And then basically we bring all of those pieces together into the code, and creating from the template, putting in the right position and everything, and voila, that's it, right? So you got your flashlight, your lighthouse, and you can keep going. But before I keep going, because I promised there was going to be a sneak peek, one thing that's we always kind of wanted to do, and we think it's going to be very important moving forward, is okay, I can do all these things, but it would be great if I can then show it to somebody else, and that somebody else can also start moving sliders and creating their own version without even touching the code. Just think about a configurator, right? So I'm going to move into my staging, because this is a Tinkercad that nobody else sees unless you are from the Tinkercad team. and this is the same code, but you'll see a new icon here that might change. So just don't take screen captures because these things can change. But basically in here, what happened is that I grabbed the variables that I used and I made them controls. So now, for example, the variable railings becomes a control that's a slider. And if I can see how it's done, it has a minimum of 20 and a maximum of 40. So you cannot put 5,000 because there's going to be a kid somewhere that's going to put 5 million there, and the machine is just going to explode, right? They do that. As you can imagine. So once that happens, so now I can just change it here and see it changes, or even more interesting, I can go to my detail page, which is on your dashboard, and on the detail page I will see I could play the code block without having to go into code blocks. Okay, this is coming. Here it's coming. Perfect. I guess it's this one. Yes. Oh, sorry, I said Tinker this. This is what happens after 12 hours of flights. I'm here and say like code blocks, right? And I get my, so for example, I'm going to say just maybe less railings and the max diameter a little bigger, but also tower height a little bigger. And then I just play it. And it's going to build it based on the new settings. So the railing is going to be less dense because it has several less than the initial one. And yeah, there you go. So after this, eventually you'll be able to then take it to your 3 workspace, which is what we want to do, because that's where I'm going to stop, and I'm going to get Maren to continue with her probably even more amazing demo on Scratch.
Well, that was amazing, Guillermo. And you see it here first, right? So we got a really cool sneak peek. Got to show up live. So just our chat question as we're transitioning on our journey from Tinkercad to Scratch, we're wondering what scaffolds or supports might help beginners succeed with a CodeBlocks project like this. So I know this is a great audience to ask this to, one, because educators are so creative about thinking about ways of making projects more accessible, but also even for newcomers, you might be overwhelmed at first seeing, all of these, all the options and all the possibilities. So how, in thinking about that, like how would you present this to students in a way that might not be overwhelming to them, that might, inspire them to just get started? So please let us know in the chat. And then I'm going to next pass the mic to Maren so that we can enter the world of Scratch. So Maren, please take it away.
Thank you. I know we have so much we are also excited to share about, and we always run out of time, right? So I will try to keep this to my 10 minutes, but we're going to try to now bring what we created into Scratch. One of the things that I really love about today's activity and this pairing is that you just saw in Tinkercad, one of the things that we're doing is we're sort of decomposing an object. We're figuring out how to break it down into its parts, into its elements that create the final form. And when we are bringing something from that 2D space into 3D space, or 3D to 2D, Scratch isn't 3D, I'm sorry. You can use those same skills, right? When you're breaking down the tasks to make it, for instance, become animated, bringing this to life. We're thinking about, do I want it to turn? Do I want it to move? What order are those steps coming in? And so this decomposition and iteration piece was really a nice flow through line for the activity today. I won't go too deep into this since we are short on time and I want to get you creating, but I just want to point out that we have some materials, if you have never encountered Scratch before, about our creative learning philosophy that I encourage you to check out when you check out this slideshow after our presentation today. But one of the big things I always like to point out is this comfort with getting stuck and then coming up with strategies for getting unstuck. So I know there's so much information being thrown at you today, and it may feel overwhelming. You may feel like I can't get my head around this yet. I say, slow it down, check this out when it's reposted on YouTube later. And you know, get yourself stuck, and that's good. Those develop those great muscles of us practicing that growth mindset that we really want to demonstrate to our students. One of the reasons that we thought this pairing was really fun too is that here you can create this object in Tinkercad, and then when you bring it into Scratch, you might say, why Scratch? I love that you can use our sort of interactive and expressive canvas, which is how I think about Scratch, to share your ideas and expand on things. So as you're going to see here, we can take this lighthouse and then do some pretty cool things with it and take it in many different directions. And I love that. And then, of course, you can publish it. You can share your project with an authentic audience of peers, because Scratch is a global platform. So if you want to share, you can share with the world, which is really exciting. And that also gives us some digital citizenship opportunities, which is always a good thing to highlight during CS Ed Week, right? If you haven't used Scratch before, I will just share, we have these getting started resources that are available on our website that walk you through very slowly how to start moving around our platform. So just want to highlight that those are there, and they'll be in this slideshow for you. But what I really want to do is dive us in. So we have just created this awesome lighthouse in Tinkercad, and now I want to bring it into Scratch. How do I do this? So what you're going to want to do is get your lighthouse, you know, run through all the steps so you're seeing it here on the screen. You can use these tools to, as you can see, sort of rotate, get at the angle I want, maybe zoom in, woo, not that much, right? Zoom out, get it how you would like the view of this object to be. And then we're going to use this share button, and we're going to choose the screenshot option. I'm walking through this as we're talking here, but I do want to point out that these instructions will be in the slide and is also in the Instructable that we are linking to. So you can, again, slow this way down to follow me through this process. So I'm going to take a screenshot. Again, here I can sort of mess with those zooms. And once I've got it the beautiful way I want it, I'm going to click the screenshot button. And now I've got this download that I'm going to use in my project. Now, when this is exported, while you won't see the work plane, you will get the white background. And so one step that's kind of between Tinkercad here in Scratch is you may choose to remove the background of this object when you create it. And you could do that with various programs. Adobe Photoshop, Remove BG is a website that does it. Lots of options. You can also remove it with Scratch. It's just a little more manual labor. So I will show you here. I'm in the Scratch platform. I'm going to hit the Create button. If you have an account, I suggest you log in, because then it will save your work as you are going along. But to bring my object into Scratch, I have to move my Zoom windows. Okay, so to bring the object into Scratch, I'm going to go down here to my Choose a Sprite menu. And instead of choosing a Scratch sprite that's already here, I'm going to choose Upload a Sprite. And then on my desktop, I'm going to choose that, that image. So here you'll see it's come in, and you can see like the Tinkercad logo, and you can see that there's a white background. If I make kind of a square, well, I can't do it on this view. It won't work. Trust me, there's a white background here. You can kind of see actually as I zoom in here. Okay, so if I don't want that, and I don't want to use the programs to remove the background, I can always use the eraser tool to erase that white background. But like I said, kind of manually intensive. So you may choose not to do that and instead remove the background with another program. This one, I did that already. I removed the background. You can see when I zoom out, no Tinkercad logo. As much as we love Tinkercad, maybe I don't want the logo on my project. So now what I'm going to do is I'm actually going to use this Convert to Vector button to convert it into an object that I can just sort of move around and resize. And I'm going to just increase the size, make it really big. And now I've got this object in my Scratch program. I can use tools to kind of center where it's going to appear on the stage. And now I might want to animate it. I want to do something with it. So for example, maybe I want to add another character or another feature to this project. So I am going to watch my time here, and I am going to create, let's say, a door on this. So I'm going to use my rectangle tool in the paint editor, and I'm just going to create a little door. And once I have that, maybe I want to create a separate copy of that. I'm just going to erase this one here. And I can use tools like this reshape tool to reshape that so maybe it looks like the door is opening. And then I'll have to create a little shadow background behind it, right? I'm just going to do that. Let's make it black. I know I'm moving fast. Bear with me. So here we got 2 costumes, door closed, door open. This is the start of my animation process. I can then go to my code blocks here, and I'm going to look around, and I see under the looks blocks, for instance, there's an option to move to the next costume. So if I do that, I've got this little animation going. Now, maybe I wanted to do that forever. Everybody loves the forever block. So I'm gonna say, okay, let's do this forever. And when I click this, we've got a wacky door. Now, just to kind of give you an example of where this can go from here. This is a more complicated example that I've shared in the project. But what you'll see here is I've actually made this into a parallax, which Scratchers love, where based on my mouse movement here, I've got some water moving. You'll see I've got this light flashing. I've got these characters in a boat. I've added some effects here where I can change the brightness of the scene and let the stars come out. So lots of different ways that I can take this project and create something cool with it. And here I've made an animation, but what I really love is that you can go a variety of ways. It could be scenery, the lighthouse. It could be a chest piece in a game. It could be the focal point of an informational project about a famous lighthouse. Maybe you replicate a famous lighthouse and then you want to have an informational project about this. So there's lots of ways that you can take this and really make it your own. So everybody's project doesn't end up looking the same. We get a wide variety, and that is what we love at Scratch. And also, I love to point out that, you know, this is also an opportunity where maybe you have a kid that's really into art, a kid that's really into coding. This could be a great pair programming opportunity. Maybe you divide and conquer, you know, the students are helping each other so that you're creating something wholly unique and you're building off the skills of students in your classroom who may be having different experience levels. So something that I just always love to point out. Like I said, you can add sound, you can add more digital drawings, you can add effects, you can move sprites around. I've got links here in the slide deck that you'll get afterwards, so you can get more resources about how to do all these kind of different ideas, as well as a link to my example, so you can see inside and see how I created this. But I don't want to lose my time here, so I'm going to zip you resources. I just want to point out, here's all of our resources. When you click on those links, you'll get into our learning library. You'll find things about using those forever blocks, those repeat conditional statements, loops, variables, all sorts of things. Okay. Let's talk about the AI piece, because we said we were going to do some AI here, and I want to highlight. So going back to that little project that we created, I'm going to grab a sprite. We don't seem to have any seagulls in here, so I'm going to use a pterodactyl. Why not?
Great choice.
Right? Who doesn't love a pterodactyl? So we're going to go, and I'm just going to grab a few of these costumes. I'm just going to delete a couple. So we have this pterodactyl that can fly. I could use that same code to kind of move through the costumes, right? And so maybe I'm just going to drag this over to my pterodactyl. So that's pretty cool. My pterodactyl's flying while my lighthouse is going insane. But now let's try out some of these new AI blocks that we have created. These are the Scratch face sensing blocks. What I love about these is they aren't storing your data. This is not recording your video. The only person who sees a video on the screen is you. We do not have pictures of you anywhere. But what it's doing is it's using predictive AI to determine where your eyes, ears, nose, or mouth are. And then you can use that to control an object. So when I go back to my project, too many tabs. And I add these face sensing blocks by clicking on my extensions menu and face sensing. One of the things I just want to point out I love, we put our AI blocks in the extensions menu so that students can choose to utilize AI or not. Not everybody's a fan, I get that. So we want to give you agency and choice, and so that's why they are in that extensions menu. But if I grab this cool block that says go to nose, and I click on it, now as I'm moving around, the pterodactyl is following my nose. Even behind the lighthouse, it knows where my nose is. And so I'm utilizing this as another input, which I think is great and a lot of fun. One of the things that I have done here is I've created a version of this same lighthouse project, but this time I'm using the tilt of my face to control the light. It's not just automatically going. And then the boat's following my mouth. And then just for fun, this is a ship, but what happens when the ship goes into the sky? It turns into a spaceship. So boom. So we've got spaceship, boat. I can control the light. The challenge is trying to get this UFO in the light. My head doesn't turn that far, but it's really fun and just a goofy, fun example way of how you can use these blocks. But one of the reasons I love these, oh, it's making so much noise. I don't know if you can hear that. Okay. One of the reasons that I love this is because I also like to think about accessibility with this. If I have hand dexterity issues, if it's harder for me to move a mouse, or maybe the keyboard keys just aren't the great solution for this, this is another way, another input that you could use. And so it's a way of using AI technology to also get at making these projects more accessible for more users. And this leads to a lot of really great conversations about design considerations, right? Why we want to use certain inputs over another. So instructions on how to use, I'm talking so fast, I know. Instructions on how to use the face sensing blocks are here. I have some information about why I love this, but I really just want to highlight multiple pathways, lots of ways to engage. Like I said, if I was back here in this original project, I'm just going to load quickly just to show you an example. Here's an example of pterodactyls following my nose. But when I touch this button, now my lighthouse is giving me a lighthouse fact. So it can be an informational project. It can be an animation. You could utilize these tools in a game. Probably hard to take me seriously with a pterodactyl on my face. But this is a really fun way of just showing that there's a wide variety of ways that you can approach this. And I think that that is important. Just like you can make your lighthouse look any sort of way, when you bring it into Scratch, you can approach it from all these different angles. So that's what I've got. I will share, there's a couple slides that are going to be in here when you get this, when you go today, where I've shared some other examples of ways to use like shapes from Tinkercad. If you're not ready for code blocks yet, potentially you use one of their pre-made shapes in Scratch. And so I've shown some examples of that here. I've shown some examples of ways that I've taken Scratch sprites and kind of converted them into their parts, right? We're decomposing so that I can then bring it into Tinkercad and make something printable. I don't know if you noticed, I'm wearing actually my 3D printed earrings of the Scratch block and the Scratch cat that I made in Tinkercad. Thank you very much, Tinkercad. They always get a lot of compliments. You know, I make all sorts of things, name tags and stuff. So that's in there. And, you know, another way to utilize Tinkercad and Scratch is to use Tinkercad to create tools that you can use with Scratch, like a Makey controller or a microbit holder. I've done that. So I've got examples of those in there too. So again, if your folks aren't ready for some of this, this could be another way of using it. Or if they've already done something like this, then, you know, try the other thing. So lots of goodies in here. I'm at time. Kellyanne, back to you.
Maren, I think that you need to talk to Dr. Amon's people about getting a show on PBS because I'd watch it. That one's incredible.
Would love PBS. I love
just
PBS.
Like the story of the pterodactyl with the lighthouse, like
right.
I mean, it's like my mind is just.
My kids watched
places.
Dinosaur Train. I thought that was a weird combination, but they loved it. So, like, you know, here we're doing Dinosaur Lighthouse.
It's a brilliant combination.
Thank you.
Thank you, Maren. So yeah, so please share in the chat what surprised you, you know, what new idea was sparked by today's conversation. Have you tried an activity like this in your classroom? And just like any tips to share with us and fellow educators. I'm loving the cross collab in the chat as well. We've got our scratchers, we've got our tinkerers, and we've created a great space for that. So super exciting stuff. So you can see my screen now, right? I just wanted to show off my really awesome lighthouses again because Guillermo loved them so much.
Speechless.
It was innovative. I'm innovating, Guillermo. So just know that with the slides, you'll be getting all types of resources, including the Light Up a Story with Code lesson plan that we've been trying to illustrate through the activities today. We really want your feedback. So please, Randy is going to put this in the chat. This is about Tinkercad. Every year we do an annual educator feedback survey. I can't emphasize enough how much our Tinkercad team really takes your feedback seriously. It's like what inspires them to make Tinkercad even better. So please, if you are a user of Tinkercad, Randy is going to put the survey in the chat. Please take it. It takes 10 minutes, but we feel like it's a great use of your 10 minutes. I just wanted to remind you that there have been questions about will this be recorded? It is being recorded right now. It will be on the Tinkercad YouTube playlist. I think Scratch also plans to put it on one of their playlists as well. And this webinar recording will be, we think is going to be available tomorrow. So the playlist link is being shared in the chat. Also, if you do this activity during Computer Science and Education Week and even do the AI extension as part of Hour of AI, if you want to share how it went, please let us know through our social channels. We'll be following your activities during Computer Science and Education Week. That sounded creepy. We're not using AI to do that. But if you do make a project or your kids make a really cool project in Scratch and Tinkercad, please use the hashtag Tinkercad Scratch Lighthouse so that we can celebrate your work. Oh, and last but not least, everyone gets a certificate. Everyone who's here live, when we send you our follow-up email with the slides, with the link to the recording, we also, if you attended live, will get a certificate that you can customize with your own name and then use it as evidence for your evaluation and your ongoing professional development. We have one last poll before we break off into question and answer. We just want to make sure that you found this useful or not. So please let us know. So the question is, will you use what you learned today? We're seeing a lot of very likely. So I'm feeling like I could use something that I learned today. So super excited about this. The opportunities. All right, so let's move into our question and answer. Thank you for sharing with us how it went. Please also let us know in the chat. We take the chat very seriously too. We make a report on it at the end, just so that we can capture all of your ideas and suggestions. So if you have suggestions for future webinars, this is the last in this series, but there will be future Tinkercad webinars. So please let us know how it went and how we could make it better. So I'm going to now stop sharing my screen. We are going to, now we're in Brady Bunch mode. Also, you could call it Hollywood Squares as well. I think is maybe more current, I guess. At least by a decade, right? So please let us know, Randy, are there any questions that we haven't answered yet?
Yes, there are questions. There's one here for the panelists that is maybe beyond my knowledge, so I promised I would ask the panelists later. They were asking about when teaching children, traditionally there's sort of a logical progression and pattern you see when they're learning, and with AI, it's a little bit more opaque, and they were wondering how do you build the guide rails and what are the best practices for teaching kids AI?
I can say that for the Scratch perspective, Mitch Resnick, who helped start Scratch, has done a lot of really nice blog entries about this. But our kind of philosophy is that it needs to expand on your creativity, not replace your creativity, right? And so we start from a place of how can these tools help you accomplish your goals, but don't do the thing for you. We talk a lot about privacy and safety and agency, which is why we have a lot of information, especially with our face sensing, about it doesn't capture your image. that it is a choice to use it or not. It's not just forced upon you. We have a lesson plan where we sort of go into more of this in detail if you're interested in those resources that are shared in the slide deck. But I think that the way that we are approaching it at Scratch is thinking about how to teach kids how to use it under the hood, but in a really fun, creative, hopefully accessible way.
Cool.
I think Dr. Millner had a comment as well, or yeah.
Oh, yeah, if we want to expand a little on that, it depends on the age. If you are having older students, think about the guardrails. You can actually negotiate them and say, this is what we think allows for amplifying your creativity. These are the cases where we're not doing these things, and there's a lot in the gray space in between. Let's engage. What do you think this would do? Let's try it. Let's find. So, like, just to allow them to see and feel out the guardrails on their own too. It doesn't feel like something that's being enforced. It feels like you can collaboratively, and teachers and educators can always learn a lot from the students as well, because sometimes they're leading out in front in this. And so inviting that in the right ways can sometimes allow us to both to all evolve together.
Okay, I have a question for you, Guillermo. Someone asked this while you were showing your lighthouse. They asked, how long does it take to make something like that in codeblocks?
Oh, I don't know, because in general, what I find is that as you are doing the code, you're also kind of exploring avenues and doing different things. So I don't know, the original lighthouse, I think it took me like 15, 20 minutes, right? But then it was like, oh, but maybe I can do this thing smarter and this whatever. And also Christian works on it a little bit too. And the templates, I had not thought about the templates because it was a one-off, so why templates? But the template is nice because you can then reuse some of the things for later. So it is not scary, right? So it's just a thing that you just, if you've never done it, start with something simple, right? And maybe just a single body, not different parts that you have to figure out how to maintain the angles and stuff like that. For example, when Christian did the piece with the red, white, and red, he did it in a way that I had not thought about, which was just hard code it, and then there's a block that resizes into whatever size you want. So when I was thinking about how to do it, I was just, oh, okay, well, almost like trigonometry, right? So what's the end of this and this, right? And what happens when you change the diameter and not change the other one? Well, that was a super simple solution. That I had not thought about, right? So there's, I would say a simple version of that takes 15, 20 minutes if you kind of know what you're, if you already know a little bit what you're doing. But as usual, right? It's like a muscle, right? So you at the beginning, whatever you start, it's gonna take a while. Start with simpler projects or something very simple, and then start adding more complexity as you need, right? So yeah, the lighthouse is a pretty cool one because it looks good, but at the end of the day, it's a lot of similar operations over and over, right? So for each of the parts, so it's not that complicated.
Okay. We have a question here about how best to provide Tinkercad learning materials to students with diverse basic knowledge or special needs. I was wondering if anyone had any insight into that.
Tinkercad has tutorials. If you go to tinkercad.com/ I think it's learn. And there's a main heading that has learn, and there are some pretty good tutorials, some baseline tutorials for the 3D workspace and the circuits workspace. And codeblocks has a few, which we're working on adding more of those, very much like stuff you saw today. But also, I mean, and so I would start there because that would set a good baseline for you and your students and get you very comfortable in the workspaces.
So the question was about special needs, right? In particular, I don't think we have anything on the tutorials about that specific tutorials for special needs. What we have done in the last years is try to make sure that Tinker is very accessible. So make sure that everything works with a screen reader, that the colors have enough contrast in case of color blindness. I mean, there's a lot of things we have been doing keyboard navigation in case that's a problem for using a mouse or a trackpad. So we've been doing a lot to ensure that Tinkercad is more accessible than before and less than tomorrow. So
I
we
would
keep working
also
on that.
I would encourage looking at the lesson plans as well. So we have on the teacher page, there is curriculum that's curated for different subject areas. And our lesson plans in particular are written by teachers. So by teachers, for teachers, and teachers are obviously always thinking about how they can make lessons more accessible. So there's a lot of like graphic organizers, and just like pointers and, ways of kind of adapting, the lesson for different learners as well. So the lesson plans would probably be a good place for finding just guidance on accessibility for like teaching a lesson in and of itself. So and the lesson plans are found if you go to the teach page or the teacher page in Tinkercad and then scroll down to the bottom, there is curriculum curated by subject. So you choose the subject and then within each of those subject areas, there's lesson plans that are linked.
All right. We received a question if Tinkercad is looking for teachers to pilot our beta features on the website.
Better question?
Yeah, if that's something we generally look for, and like how might someone get involved in that?
Yeah, so we have what we call a teacher advisory board. Is we have in the course of time we found teachers either maybe at conferences like ISTE or people that participate in forums or anything. And when we find a teacher that is really wanting to provide quality feedback and spend some time looking at these things, we normally offer them to be part of the teacher advisory board, which basically just give you access to not to beta itself, but just like to a little early release of some things, so you can give us feedback on how things are going, or if it's clear, or if we need a little more polishing. Christian handles the program, so I would say if anybody is really interested in that, we should just let us know.
Maybe email us at tinkercad.support@autodesk.com because I read those. But yeah, we actually have a teacher who helps us out with the code blocks. And if you go to the code blocks gallery on tinkercad.com, you'll see a lot of his stuff up in the top of the staff favorites. So
yeah, I mean the only thing we did ask is once because we cannot have like hundreds of people there because of at that point we just throw a survey and it's the same. We need kind of more like quality time. So we also need, I mean, sometimes there's enthusiasm to participate, but then we have crickets because then there's no time to work. I mean, if we add you, the only thing we ask is just some time in return to look at whenever we have something for you guys to look at, that you actually give us some feedback.
Okay, we have a burning question here in the chat. Someone's asking, what are bundle groups?
I think we have your guy here to talk about.
Not a burning question. Come on.
Oh, check out was that the first episode of this series? Yeah. We have it in the recording on our YouTube channel, and it'll tell you all about it. So
yeah,
it's very simple. I mean, if for example you have two objects, right, that are not touching. I mean, sometimes you want to. Until now, the only way to make a single selection of something and then be able to do something with that thing, like move it, rotate it, whatever you wanted, was to make a group, right? So a group could be a table with 4 chairs and nothing was touching. I mean, the table 4, because it would be kind of weird to have the chairs on top of inside the table, stuff like that. But on the other hand, you had sometimes you want this cylinder and this box, the cylinder is attached to the box because you want a hole in the middle, or you want like a tower, which is a cylinder, and then a box on the bottom, which is sort of the entrance, right? So, and then that to be a single object. At that point, you would group it. And now what we do on those cases is called a union group. The union group is the group that actually does a union or a subtraction or an intersection on the object, right? So it makes if we're gonna get fancy, it makes a Boolean operation between those, right? And it creates a single mesh, a single object. Sometimes, again, when you have 4 chairs on a table, you don't need to make a single object of that, because we have to evaluate, we have to do a lot of math in the background to actually find that there's no mesh, no individual mesh. So it's just we're overcomplicating the scene for no reason, right? So in that case, when you bundle, and you'll notice it's super fast, bundle is just putting stuff together to make them work together. The reason it's called bundle, in every single other application, that's called group, but we had the word group already taken for what we call as group, which is the union group, right? And we were not going to be changing a word that has brand equity for the last 13 years, right, into something else. But yeah, now that's why we rebranded the group to union group. And there's another type of group, which is the bundle group, which is actually just things that are together in a selection, but are not really together as a single body. Does that make sense? I think table and chairs is the best thing. I mean, you don't want a table and 4 chairs as a single object ever.
Okay, and then there's one more question, sort of a question. They were asking about what if code blocks carried through between circuits, code blocks, and the 3D editor, such as SimLab, and it would like all work together, program all of it.
Just wait for probably a webinar in I don't know, maybe a half a year or more.
You hear it here first.
I didn't say anything.
We'll edit that from the recording.
I was extremely vague. I mean, eventually we want, I mean, if we have 3 workspaces and we want to talk about an ecosystem, the things have to talk, right? So right now, for example, we have every single element in circuits is on the 3D workspace as objects, right? So you can actually put them together, or maybe just to size something and know what's the enclosure, stuff like that. But we're not bringing the behaviors into that, right? So if you're in code blocks today, you can export a code blocks to a custom shape. So then you can use it on your shapes panel on the 3D workspace. What I just showed you, it will give more options there, because you'll be able to also kind of use a slider to change it, right? So we are definitely in a path of putting things together, right? So if you think about Autodesk in general, right? So we have products for engineering, for architecture, for construction, for entertainment, right? So and each of them individually are really good, but the cool point is that they can actually work together, right? And that point is it's unbeatable, right? Just because you can survey a terrain and take that into Revit and use it also for a simulation and drop, I don't know, Godzilla or the pterodactyl, because we didn't have a seagull, kind of flapping on top of that thing and getting the dust as particles from Maya just coming out. So eventually you can get there, right? So on Tinkercad, we kind of want to do the smaller version of that without making it completely complicated too, right? Because we want to keep the product simple, because that's what makes Tinkercad. If you ask me what's the soul of Tinkercad, is that it's simplicity and power, but the power is kind of contained in that simplicity. Otherwise, it will be another professional product, and we have many of those.
Randy, should we end on pterodactyls? Or are there more questions?
Yes, there actually is one more question.
Okay.
I'm
hoping it's about pterodactyls.
Unfortunately, I feel we should answer it though. Someone's asking, are there official certifications for Tinkercad or Scratch or any similar programs out there?
We could go first on that. In fact, there is. So there is a Tinkercad 3D design certification. It is appropriate for both educators and students. And I'm wondering if Nicole or Randy, if you have the link. We have a blog post that we wrote about it, and it's actually pretty new. We just launched it. We talked about it in the first webinar in September. Yep.
And I'm not sure. I think it started as US only, so I'm not sure if that changed. Yeah, so I'm just a caveat there. Just check out on the documentation, because those things change fast.
And we also do have, and we reference them in the lesson plan for students as kind of micro credentials. We have digital skill badges. So the lesson plan that Maren and I wrote together, that has been shared with you, Light Up a Story with Code. It aligns with the coding badge, but there's also different paths that students can take as they're remixing their lighthouse. One is architectural, one is kind of more about like sustainability, one is kind of more digital artist, and we have badges for all of those too. So it's a fun way to reward your students for their creativity and to acknowledge how much they've grown. Are there Scratch certifications?
We don't have them at the moment. We had an SCC program that's currently sort of paused and being reworked, so I don't have anything that I can share at the moment beyond at some of our webinars. You know, we do offer the PD certificates and things like that at the moment. But I would say register for our newsletter, follow us on socials, and when things like that get announced, you'll have it.
Cool. And the one thing people have been asking about all night is where to get Tinkercad and Scratch t-shirts. I don't know the answer, but people seem to really want them.
We have a Scratch store, so I know where you can get Scratch t-shirts, and I will put it in the chat.
Yeah, Tinkercad, you just have to come find us, and we will give you one.
Anything else, Randy?
I think that's it.
Okay. Well, this is the point in the webinar. I want to thank everyone who came and presented tonight, but also to thank all the teachers who joined and just made this really fun. I'm excited to go back and read the chat and all that you're saying. I see it popping up every once in a while, and it's making me intrigued. So thank you everyone for staying engaged, staying positive, and connecting with each other and helping each other out. And just also huge thanks to our friends from Scratch. It's when I was a teacher in the Boston Public Schools, I was an English teacher, and I got in trouble for teaching Scratch in my classroom because my new principal didn't quite understand the interdisciplinary nature of teaching computer science. So this is especially rewarding for me to be able to work with Scratch on this project. It's come full circle. So the Scratch actually wrote a kind of spiteful tweet after that happened, and then the Scratch Foundation retweeted it. Because I was talking about how, like, like a sprite, like the sprite, like you can talk about the parts of the sentence, and like costume is kind of like a modifier, like whatever. It was funny. And
No,
also,
I love that
Dr.
we're doing this together. I will just say thank you for having us because obviously I'm obsessed with also creating 3D stuff with your product. So loving this.
And we've literally been planning this, I think, since like early spring. So we're just so happy that it's happened. And also, thank you, Dr. Amon Millner. You've made, I think, AI seem less scary, more fun, and just like hopeful. Like it's a way of, a way of engaging us and thinking about how we can shape it for the future and make it for everyone. So I don't know if you have any final words, Dr. Millner.
It's a pleasure, and it's always exciting to see where everyone is coming from tonight in the chat and the engagement and the reactions that are floating through. So we couldn't do it without your energy. Appreciate you all.
100%. All right, so this is when we do the awkward wave. I think mine is going to be inspired by a pterodactyl. I'm not saying anyone else has to do that, but we're going to say goodbye to everyone. Do our awkward wave. Ooh, that's a good one. I like that. All right. Nicole, you think this is enough? We make a funny GIF with this too at the end. All right. Thank you all. Good night. Take care.
Bye.
We'll see you soon. Bye.